Good afternoon, everyone. I am Nishtha Gupta, the Executive Marketing Director at IndiaIT360, and it is my pleasure to welcome you to today's exclusive session, Cloud Native to AI Native, Rethinking Network Architecture. AI is no longer experimental, it is foundational. As AI workloads scale, traditional cloud native network designs are being pushed to their limits. And today's session, we will help you understand how AI workloads reshape network demands, what differentiates cloud natives from AI native architectures, and how to eliminate latency and throughput bottlenecks. Finally, we will also dive into how to design resilient, AI ready network foundations. We are honored to have with us Mr. Raghav Kathuria, the Senior Product Manager at Lightstorm. Raghav brings deep expertise in next generational networking and works closely with enterprises building high performance, AI driven infrastructures. We truly appreciate your time and insights. Thank you for being with us today. Before we begin, a few quick notes. We will have a Q&A segment at the end. Please drop your questions in the chat throughout the session. The best question will receive a special prize. Stay until the end of our exciting Spin the Wheel segment where attendees stand a chance to win one gift voucher worth rupees 2000 and three gift vouchers worth rupees 1000 each. So stay engaged and the session will be insightful and rewarding. Now, without further delay, I would invite Mr. Raghav to take the session forward.
Thank you, Nishtha. Thank you for setting the platform. And I'm pretty excited to take up this session and uh, ensure that I'll be able to communicate well with respect to what we intend to achieve as an outcome from this webinar, which is how industry is shifting from cloud native architecture to AI native architecture, what changes are happening, and how Lightstorm as an organization is taking huge and relevant initiatives for this movement. And Okay, so as the webinar topic suggests, that we will be evaluating that how the cloud architecture is moving from AI-driven architecture, and what enterprises are taking initiatives, and what Lightstorm has a role to play upon when we are rethinking the network architecture. So AI, we strongly believe it's not a buzzword anymore. It's happening. It's surrounding the decision making for the CIOs, CTOs, and the organization are taking a leap towards it. But when we talk about how to implement it, how to optimize it, how to take the maximum output from the AI generated models, AI driven networking, and as well as the business outcomes, we tend to uh, lack in that piece. So, by the end of this session, we will make sure that you are able to witness that how the industry is shifting and what has been the new priorities for the organization now, and how the AI networking architecture is building up, and what things matter for different type of AI workloads, different type of training modules, inference modules, etc., and why the traditional network is falling short, because we can't rely upon what we did for the voice driven architecture or cloud driven architecture, etc. AI driven architecture demands something else. And then we will see that how Lightstorm solution is taking up and what we have to offer, making the initiatives very much aligned with Lightstorm offerings. And in the end, we will definitely have a demo what we have to offer as a platform demo by Mr. Yash Sharan, who is the product manager with Lightstorm for the cloud networking. And to start with, as I mentioned, that industry is taking a leap towards the priorities towards the network architecture and how it is shaping up very abruptly. So, as during the start of the session, it was highlighted, AI is not buzzword. AI is not a bubble anymore. It is something that is happening surrounding us, and the business are being impacted heavily. So when we talk about the current cloud architecture, which we are running as an organization, which we are developing as an organization, the cloud adoption or the cloud architecture is completely north-south traffic driven. User interact with the database, database interact with the application, and application eventually interact with the user. So that's the standard flow of traffic that happens in the cloud driven architecture. Enterprises set up a multi cloud or a hybrid cloud architecture, ensure the data movement happens smoothly, and there can be a private connectivity or a public connectivity. And of course there is more north south traffic, as I have mentioned, in the cloud native architecture. But when we move towards the AI driven architecture, which does not only rely upon the data movement, it requires something more. It is not just restricted to high bandwidth that you can fine tune and set on the cloud native architecture. It requires the network which is deterministic in nature, which is with ultra low latency, which is with definitely some movement where data is closer to your users, closer to your application, and definitely the GPUs that you are deploying are able to communicate well with each other, right? So unlike cloud architecture, here we are majorly driven by the GPUs who share vast amount of data with each other, which is known as east-west traffic flow between one cluster of GPUs to another cluster of GPU, right? So when these GPUs are talking to each other continuously, it becomes very important that the network which is connecting these GPUs is able to scale up, scale across, and able to accommodate these type of data movements. Now, when we talk about the workloads, right? So, cloud driven workloads demanded elasticity. We all are aware that cloud like AWS, Azure, GCP, Oracle, they ensure that enterprises gains the flexibility, elasticity as per their business demand. Right, there is virtualization, there is cost efficiency. We have all enjoyed it for past few years now. Now, since the industry is shifting towards the AI workload, which is more data driven, more deterministic, and the latency factor is not at a millisecond now, it is running at microsecond. So the pressure on the network architecture is much, much higher now. We can't just increase the bandwidth of the cloud set architecture and ensure that and expect that it will work for the AI workloads as well. This won't happen, right? AI workload, which needs to be optimized, requires the data movement to be in place, which is closer to your application, closer to your users. It requires deterministic performance of the network. It needs to be SLA driven. It can't run on the public internet at all. And definitely the GPU utilization when they are communicating with each other needs to be maximum, because when your GPUs are sitting idle, you are losing heavy amount of money. We'll see in the upcoming slide that how much money and probably how much impact does it make for any business when their GPUs are sitting idle because of a wrong architecture. And of course latency, as the name suggests, latency is the new currency, and it's a bigger currency now for the AI workload. And when we talk about latency, it is now running at microsecond scale, right? So when we talk about the changes, the core changes in the networking piece, as I have mentioned, AI inference, where users are interacting with the trained models of AI, are being the latency sensitive. It needs to be distributed to different environments so that one environment is able to talk to each other. And of course, with limited data center space, limited cloud space, one environment can't hold the entire AI workload, right? So that's why the distribution of the environment is required. And these environments need to talk to each other at a latency sensitive network. And there is a new term, there is a I would say a very significant term in the AI workload, which is known as tail latency. how the entire packet or the how the entire data movement is keeping up when we talk about the latency. So it's not just a single front loaded or middle loaded latency that we need to take into picture, or the average latency that we need to take into picture. We need to ensure that all the packets or all the data movement that is happening uh, are being moved to a deterministic path with the highest of uptime and the lowest of latency. So the P95 and the P99 tail latency values should be something that enterprises need to monitor. P95 would be the figure where 95% of the traffic latency is lower than this particular value. So if I'm saying that my P95 value is 100 millisecond, so that means 95% of the data that is has been transferred at a latency lower than 100 millisecond. So that's how it is being read. And when we talk about the evolution of the networking, when we talk about public connectivity, internet-based connectivity, which used to work on the best effort basis, now it does not need to work upon the best effort basis. The routing, the deterministic path need to be robust in nature, because any scale, any glitch in the GPU communication can make your GPU sitting idle and underutilized, which definitely can deep down impact the pockets of the enterprises. And of course, when we talk about the power capacity, the availability of the space and power for the data center spaces in India specifically, most of the spaces are unable to accommodate these heavy GPUs. So to accommodate this, to resolve this, we'll see that how network architecture can be distributed for different AI inference and AI training workloads. So let's understand the AI networking piece. So when we talk about the complete AI development and AI adoption, we have seen the recent AI summit that happened in Delhi. We have seen certain enterprises running AI conclaves, and the outputs that we have seen on daily basis. We interact with different models and different AI platforms like ChatGPT, Gemini, etc. So behind these platforms, there are the three pillars that are running and that are ensuring that the output that you get is robust and well developed. Right. The first one is, which are the three pillars of AI development. The first one is the models that you run upon, which is LLMs. The second one is the infrastructure, the digital infrastructure, and of course, which includes your compute capacity, the GPUs, and the third one, where we will be focusing upon, is the fabric, which is connecting all these GPUs with each other, which is the network as a service model that we'll be talking about. The fabric, which ensure that the data movement, ensure that the communication between the GPUs, the latency, and the output that is generated to the end user is quickest of time and the with the lowest of latency. So when we talk about the two common terms of AI workloads, which is training versus inference, in simple terms, when GPUs are talking to each other, which is east-west traffic, uh, they can be located in a single data center or can be across data centers. When they are talking to each other and sharing the data with each other on regular basis, on daily basis, and in probably in microsecond basis, this is majorly for the training purpose, right? They are constantly sharing data, getting trained, the models are being built, and it's a heavy amount of data. It's of huge scale, huge deterministic path bandwidth is required for the GPUs to constantly talk to each other, so that these GPU clusters can act as a one single big cluster who is constantly exchanging data. So imagine a scenario when the communication between these GPU is impacted or is being uh, uh, obstructed by the networking glitch. The impact on these GPUs will be that the entire cluster or the entire GPU set will be sitting idle. The entire motion of the data will get impacted, right? So that's how the training of the AI workload becomes very critical when we talk about the GPU to GPU communication, right? Which is the east-west traffic, which you are seeing the right-hand side of the diagram, right? And when we which is this model, right? When we talk about the north south traffic, which is the left side of the diagram, where users are interacted with the trained models, right? So there are models like DeepSeek model, the Llama model, the GPT model. So they are pre-trained models where users interact with these models, share the data, or probably uh, fine tune it for their customized uses, etc., which is known as the north south traffic, which is definitely comes under the AI inference piece, right? Where you are interacting with the trained models as of the picture which you are seeing, right? So different network metrics are being utilized, and different network metrics happened to be taken care of when we talk about training and inference. So for training, where the data is being generated from GPU to GPU, it requires a deterministic path. It needs to be SLA driven. It can't be on public internet, and it needs to be jitter proof. When we talk about the inference part of the traffic, which is the north south traffic, it needs to be distributed, latency proof, and definitely user facing, so that multiple sessions where multiple users are interacting with the trained models, they are able to get the output token to the lowest of time. Right. So these two figures, which you are seeing on the screen, clearly signifies that how the difference evolved, or how the difference came into picture when we talk about the cloud-ready architecture or the AI-ready architecture. The left side of the piece, you can see more like a digital superstore. Right, we log in into AWS console or Azure. We see what are the compute that is required, what are the storages, what are the database, etc. So we have a complete superstore in front of our uh, uh, screen, right? More like a service catalog that we can create and optimize our application accordingly, right? Which is the user interacting with the compute, storage, database, etc., which is a typical example of the north-south traffic that is running, right? When we talk about the AI factory, which probably these the hyperscalers, the neoscalers are building, the AI factory requires the constant communication between different GPUs, between different GPU models, GPU clusters. Uh, Within the same data center, across the data centers, etc. So these communication needs to be optimized for the AI workload. It requires a symmetrical data flow. It need to ensure that the tail latency figures are lowest of its value, which is of microsecond scale, and requires a high performance architecture, so that the GPUs are definitely overly optimized and are not sitting idle. So the complete architecture that you're seeing the difference has evolved from cloud architecture, as now is different from the AI factory, which the neoscalers and the hyperscalers are creating. So that's the complete difference between, I would say, a tale of two clouds, which we are seeing on this slide. And that's the summarized view, where we talk about the digital superstore, which is the hyperscaler cloud architecture, is more towards the variety of the resources that you can deploy for your application, right? You get thousands of resources, you can provision it, use it there and then, start and stop whenever you need it, right? Whereas the mission for the AI factory, it's more towards the performance and depth, right? Where the performance of the GPU communication matters a lot. How your AI model is being created, is being utilized, is being communicated, right? And when we talk about the connectivity, the general connectivity works with the cloud architecture, but for the AI level architecture, you need a high capacity optical fabric. We can't even think of having public internet based connectivity when we have GPUs talking to each other, when we have numerous users to talking to trained models, and the cost, we can't even imagine that how it will impact us, right? So, moving on, when we talk about the traditional network, that how it is designed and how it is being given in front of the enterprises, they are definitely not accommodating, I would say, that they can accommodate the AI workload or the AI driven architecture, which requires a deterministic path to be in place. Why is that so? So when we talk about the AI driven architecture, the core challenges, as we have already discussed in the previous slides, is majorly with respect to the space and power. Right, so GPUs, which are huge in number, requires high amount of capacity. We must be aware of this fact that power and cooling capacities for these GPUs are very, very high. So not a single a data center will be able to accommodate it. Probably it can do it today, but 2 years, 3 years down the line, as we expand, uh, a single data center, it will be very tough to accommodate these type of power and cooling capacity requirements. Right. So there are power constraints in the data center. So there are definitely need for applications to be at edge, and definitely different models are being deployed. So for this architecture and for this requirement to work well, we need a distributed inference environment. And by distributed inference environment is you deploy GPUs probably in different data centers, or probably some GPUs in cloud or some in on-prem setup. So that distribution is required so that your compute capacity, first of all, is closer to the user, is closer to your application, and definitely at different sites, but closer to each other, so that they can talk to each other, so that there is no constraint or no pressure on a single data center with respect to power and cooling capacity. And when we are setting this kind of architecture, the traditional telco network or traditional WAN struggles a lot to ensure that these distributed architecture or distributed environments talk to each other efficiently. And definitely, when we are trying to expand this environment to have a distributed environment, uh, we struggle a lot with respect to scaling of these resources because of the lack of robust network, and lack of sizing capacity, and lack of the right vendor who can deploy this scale across and scale up architecture for us. And when we talk about the challenges of these network architecture, today the network architecture is majorly designed either for the voice, like we have seen certain players which are delivering our services, the major telco players, or they are designed for the cloud, right? But when we use this existing architecture for this AI workload, the latency and jitter challenges will come hand in hand. So, hence the challenge of having the distributed inference uh, is a bigger challenge that we can even think of. Right. So when we talk about the networking, because networking changes, this is more like a summarized view from tenancy. It has shift from shared to dedicated tenancy because you need a dedicated path for GPUs to talk to each other. Now, north-south traffic, uh, inference for inference, it matters. But yeah, for the training piece, it has moved from east-west traffic that we are talking about. Latency now, it needs to be at the microsecond scale and need to be economics defining, right? And the connectivity medium, it cannot be public internet. And from public plus private connectivity, which we used to have in cloud, now it requires a private and deterministic path. Capacity, which used to be in few Mbps or probably a few Gbps for to connect to the cloud, now we need a capacity of multiples of 10 Gs, multiples of 100 Gs, 400 Gs, etc. Because we are training these high, probably I would use the word monster GPUs to talk to each other with a petabytes of scale of data, right? And the architecture, of course, the core pillars of these architecture, in case of cloud, used to be compute, storage, and application. These three used to talk to each other, and that would have been enough. But in case of AI, the story has shifted from compute, storage, networking, and application. So you can see the word networking has been inserted very well in these three pillars, pre-existing pillars, where the role of networking is as critical as the infrastructure, as critical as the models that we deploy, right? So when we talk about the economic impact, so we have understood that how the latency varies a lot, how it matters a lot for the training and different type of AI workloads, how the deterministic path matters a lot. But what happens if we fail? Right. So when we talk about the latency sensitive GPU workloads, uh, imagine a scenario where any enterprise or any neoscaler has deployed 10,000 GPUs, right? Now, even a 3 millisecond of latency improvement, 3 millisecond is very, very short, right? 3 millisecond of latency or network improvement can translate to savings of $5 to $7 million on a 10,000 GPU deployment. And that's over a span of 5 years. So that statement says a lot, that how a millisecond of fine tuning of your network architecture can impact millions of dollars and can save millions and dollars of GPUs deployed, or the expenses that you have incurred for building the network architecture. Right. So when we talk about how it will be saved, of course, for a well optimized network architecture where latency is super low, your GPUs are constantly talking to each other efficiently. Your GPUs are not sitting idle, and probably when your GPUs are not sitting idle, they are working day in, day out. You might require lower number of GPUs, and we all understand that how expensive the GPUs are, right? So when we continue this statement, which is 3 millisecond of network improvement, that is equivalent to 140 to 250 fewer H100 class of GPUs, right? H100 is probably towards the expensive side class of the GPUs, right? So when your network is optimized, you might require lower number of GPUs, so because your existing GPUs are well efficiently optimized and they are not sitting idle, right? So now we understand that how economic frame works when we optimize our network, and how the advantage of latency can turned out for having a SLA backed network architecture to give you most out of the architecture that you have created for your AI workloads. So when we compare the different type of latencies on that piece, uh, when we compare the TTFT, which is time taken for the first token. If I explain TTFT, so when you are giving a prompt to, let's say, ChatGPT or Gemini, uh, the time taken for your output token on your input prompt is your TTFT, right? So it needs to be lowest of time so that user has the better experience. And when we talk about the TTFT value, the blue indicates the Lightstorm fabric, right? So the network architecture the Lightstorm has defined or created with some high-end technologies, your TTFT value is reduced to a considerable amount of time, and we'll see how. Right. So now here I will introduce Lightstorm, and as a company, what we are doing, what we have to offer for the AI workloads, because we have talked enough about how important it is to set up a right architecture, what economic impact it has created if your architecture is wrong, and what network metrics matters a lot, but how we are solving this. Uh, we have defined the problem, we have understood the gravity of the problem, but now let's dive into the solution part of the problem. Right, so Lightstorm as a company, we provide the digital infrastructure or the network infrastructure for cloud and AI workloads. Right, the network that Lightstorm has defined or created in the past 5 years, it's not for the voice, it's for cloud and AI. And why cloud and AI? Because when we talk about the movement of data between the network, between the different network environments, it requires a deterministic path. It cannot ride on the voice created network architecture because it involves topology. Right, so you cannot ride a cloud or AI workload data on a ring topology architecture. It requires a let's say pop to pop highway architecture or a leaf and spine architecture, so that the latency is ultra low, the uptime is of maximum value. And that's how Lightstorm has designed its network, which is definitely future ready on that piece. When we talk about the current capabilities of Lightstorm, we have already deployed 1500 terabytes of capacity across the globe. 30,000 plus kilometer fiber is already running in India. 250 plus data centers are deployed. And when we talk about metro latency, it is less than 1 millisecond, better than any latency that is being offered as of now, right? And in the traditional setup, it is 30% lower than the traditional telco latency what we offer. As I have mentioned, the network that we have designed help us to achieve that type of latency. And this is the network view that I was talking about. The right side of the network that you can see involves ring architecture, which is designed for the voice, right? So for the mobile or definitely for the voice data to be transferred from one location to another, this ring topology is definitely favorable, right? But it involves certain add and drop location, hops, and multiple scenarios where your latency can hamper or get affected a lot, right? But on the left side of the architecture that you're seeing, which is Lightstorm designed architecture, which is completely on the DWDM network, it's more like a highway. So if you are connecting your workload in Delhi to workload in Mumbai, it's like one highway from Delhi to Mumbai. No hops in between, no ring topology in between, and definitely latency 30% lower than what existed with traditional telcos, right? So it's the power of the network that we are utilizing. It's the power of the architecture that we have created for cloud and AI, and all the points that we understood for the criticality on the latency, criticality on the jitter, and tail latency, deterministic path can be easily gained out of Lightstorm architecture that we have already deployed, right? So this is more like a scenario where, let's say, any enterprise who wants to deploy GPUs in different sites, as you can see in the diagram, there is a site A where certain number of GPUs have been deployed. Then there is site B, where another set of GPU cluster is deployed, and site C. Now, when these three sites need to talk to each other and that too on a single robust architecture, so that these sites are considered to be a single site, they can run totally on a lossless network of Lightstorm, right? So these sites can ride on Lightstorm's backhaul, which is definitely AI ready. And if you want your cloud environment to talk to your GPU on-prem network, definitely you can add your cloud environment to the Lightstorm's network on a fly. So on this network, to make your journey of provisioning the network and provisioning the architecture a game of few minutes, we have built a software-defined orchestrator, which is known as Polarin, right? Which is network as a service platform. Through Polarin, your entire user journey, from starting from provisioning of network, starting from deciding what architecture to bring in, and monitoring your network, entire life cycle is being software defined. So do not need any technical knowledge or network experience to provision a network. You select a site A, you select a site B, the number of GPUs, the cloud you want to connect, the bandwidth you want to have between these three network endpoints, and place the order. It will be done and dusted there and then, right? So that's the orchestration and life cycle of the Polarin platform I was talking about. So starting from day zero, which is customer onboarding, day one, which is product catalog and service provisioning, to day two, which is performance monitoring, control panel, administration, etc. You can do that on a single platform, right? So as easy as it sounds, it is actually that easy that we will see definitely during the demo of the platform. And like you provision cloud, virtual machines, storage on AWS console or Azure console, you can do that network provisioning on Polarin there and then, right? So all those scenarios, all the network provisioning, the customer buying cycle to provision it can happen on a single Polarin platform. So this is the complete network visibility that you get when you provision any network. So it's not enough just to provision and deploy or connect to network endpoint. Monitoring of the network is very critical when we specifically talk about AI workload. As we have discussed in the previous slide, the latency metrics like P95, P99, the jitter value, the packets in and out, the SLA, all these metrics matters a lot and requires a constant monitoring. Now, Polarin platform also solves that scenario where all these network metrics are represented in a single dashboard screen, which is known as Vista by Polarin, right? So, on a single dashboard screen in a more interactive way, in a graphical representation, so that you can see how your network is being performed. And of course, when we talk about who this is for, all the neoscalers, all the hyperscalers who are planning to or probably offering GPU as a service through their platform, through their product as a service offering, and enterprises who are planning to connect their GPU workloads with their data origination centers, which can be, let's say, on-prem data centers or cloud environments. And wherever there is a connectivity required between GPUs or between users and GPUs, your question or probably your solution is with Lightstorm, where the connectivity plays a huge role, right? So it's a complete API driven provisioning that happens on Polarin, and it's completely multi-tenant, and we definitely back it by the SLA of different class, depending upon how much uh, gravity or how much robustness you need with respect to your architecture. And that's the improvement we have been able to create for multiple customers when we talk about connectivity between AI workload. So customers have witnessed when we talk about the inference response, there is 15% improvement on throughput, 60% reduction in time to first token, the metric that I mentioned in previous slides. Right, 60% reduction is pretty huge, and definitely 40% reduction in the latency. So these metrics says a lot that how architecture, how right vendor, uh, a service provider or a network provider plays a critical role when we talk about creating the right architecture. And this we have already discussed that whenever you improve the latency by certain factor, how much economic impact it creates. Right. So a 40% reduction in the latency, you can imagine that millions of dollars of savings when you deploy large scale GPU clusters over 3 to 5 years of timeline, right? So all these factors we are able to create for our customers. That's the value proposition we bring on the table. And over and above the network architecture that we create, there is our solution, which is network as a service solution, definitely suitable for industries like digital native business, ITES, BFSI, and media entertainment, all these enterprises where the need is there with respect to connectivity of AI workload, cloud workloads, data center connectivity. Polarin solution has got it all. You just log in onto the platform, connect the two endpoints or three endpoints, uh, and it will be provisioned there and then. Right. So everything and anything happens on private connectivity. We do not use public internet in between, and of course the latency is of lowest of value, as I have already mentioned, and you can create a agile environment whenever you want. So you can scale up and down the bandwidth that we will see in the demo by Yash, and that will switch to the demo now. So Yash, over to you.
Hi everyone, good afternoon. My name is Yash Sharan. I am part of the product team. I handle the cloud portfolio, and I will be giving you a demo on how you can do, our NAS platform, which is Polarin. How you can spin up a multi-cloud connectivity in a matter of minutes, in just 3 to 4 simple steps. So this is the website from where you can access the platform, which is polarin.lightstorm.net. The sign up is free. You can do a sign up, verify your email, and then log into the platform. So once you log into the platform, this is how the platform looks like. Before I begin with giving you the demo, let me give you a quick walkthrough of the platform. So this is the services page. Under the services page, whatever services you have configured with us, whether it's a DC to DC, DC to cloud, cloud to cloud, all of those services will be visible to you over here. So they are majorly categorized into three components: ports, virtual routers, and virtual connections. So ports come into the picture whenever you are connecting data centers. Virtual routers come into the picture whenever you're doing a layer 3 hybrid or multi-cloud connectivity. And virtual connections are basically your bandwidths that you're using to connect your data center to cloud, cloud to cloud, or data center to data center. Then you have the activity log section. Whatever activities are happening on the platform, whether it's as simple as logging in, logging out, or creating a particular service or a service going live, all of those activities are captured here in this particular section. Under the organization section, in the profile section, once you do a sign up, you have to do a KYC where you upload your certificate of incorporation, letter of authorization, all of these details, and complete your KYC so that your profile is approved and verified. Under the user management section, you basically have five roles: system admin, network viewer, finance admin, and finance viewer. So system admin is the person who has the maximum authority. He can add, remove users, change the roles of particular users. Network admin can make changes to the connectivity setup, whereas network viewer can only view them. Similarly, finance admins can add, remove GST bills, whereas finance viewers can only view them. Then under the billing section, in the billing profile, you add your particular profile against the entity which you want to be billed. And in the subscription and invoices section, whatever services you have subscribed to, whether it's a virtual connection, port, or a virtual router, all of those details, along with when the subscription was started, what is the billing cycle, what is the term, what is the status of the service, all of that will be available to you over here. And under the invoices section, from here you can go ahead and download your invoices once it has been generated. So this was a quick platform walkthrough. Now I'll show you how you can do a quick multi-cloud connectivity in a matter of minutes in three simple steps. So first you can go over here on the create button, go to show all services. So here you can see we have the use cases available as well, which is cloud to cloud, DC to cloud, DC to DC, DC to IX. Then you can individually also configure a port or a virtual connection or a virtual router. So the first step is to create a virtual router. So you can place this virtual router in any data center location where we are present, which is an on-net for us. So let's say for demo purposes, I am placing this virtual router in entity Mumbai. I click on next, then you can give this particular virtual router any name as per your convenience. So let's say I name it as webinar demo VR 2720. We also have the option of PayG apart from the fixed term contracts ranging from 12 months to 60 months. So as you can see, you will get the VR charges of what we charge for per hour basis. So for demo purposes, let's say I choose 12 months and no upfront payment. So you will also be able to see the price summary over here, which is of course the list price. Once you've configured this, you can go ahead and click on next. Then you can choose your billing cycle, whether it's monthly, quarterly, half yearly. Let's say I choose monthly. I will provide the purchase order details later. Choose the billing entity. It generally automatically fetches the billing profile that the particular service has to be billed to, basis on the location in which you're placing your virtual router. Then I go ahead and place the order. So once the order is successfully placed, it will automatically take you back to the services page under the virtual router section. So as you can see, the virtual router has been successfully created and we have been redirected to the services page under the virtual router section. Now, as you can see, this virtual router was created and it is in the awaiting deployment state. So let me just refresh it once more. We'll give it a minute or two for the status to change to live. Yeah, so as you can see, within a minute, the virtual router has gone live. Now, once your virtual router has gone live, the first step is successfully completed of creating a virtual router. Now, the next step is to connect your virtual router to your A-end cloud. So over here, you can see these three dots. you click on this, go to add connection. Now this is a multi-cloud connectivity setup that I'm showing you. So I am connecting my virtual router to my first cloud. So I will choose the cloud option. Let's say I take AWS. Now it will give me the option to choose the on-ramp location. This is basically where the handshake happens between Lightstorm and AWS via APIs. So let's say I take Equinix MB2, I enter my AWS account ID and click on next. Now it is asking me to set up the virtual connection from the virtual router towards the AWS cloud. So again, you can name it as per your convenience. So let's say for demo purposes, I name it as VC VR2 AWS 2702. Rate limit, let's say I choose as 100 Mbps. Here also you have the option of PayG, again, which will show you the hourly charges if you choose a bandwidth of 100 Mbps connecting to cloud. And also along with that, you have the subscription terms ranging from 1 year to 5 years. So let's say I take 12 months, no upfront payment. Again, you will see the price summary here. This is of course the list price for the particular connectivity that we are spinning up. Then you go ahead and click on next. Here again, you can choose the billing cycle. Let's say I take monthly. I will provide the PO details later. Again, it has automatically fetched the billing entity for Mumbai, since my on-ramp location is also in Mumbai. Then I go ahead and place the order. Again, once the order is successfully placed, it will take you back to the services page under the virtual connection section. So as you can see, we've been redirected under the virtual connection section. So this is at awaiting to deployment. Now a ping, the AWS account ID that I entered, that console, your AWS console will receive a ping. Once you accept that ping, your cloud connectivity towards AWS will go live after you have configured it. So the first part is done where you've connected one cloud. The second step has also been completed. Now we go to the third step. We've created the virtual router successfully. We've connected AWS cloud. Now I want to connect my other cloud. So again, it will be the same step. Click on these three dots, go to add connection. Again, choose cloud. This time we choose Oracle Cloud. Enter the service key, verify it. Once this is verified, again, now it will give you the option to choose the on-ramp location. Again, this is where the handshake is happening between Lightstorm and Oracle, this time via APIs. So let's say I choose Equinix MB1, I click on next. Now again, I'm creating a virtual connection from my virtual router towards my Oracle cloud. So again, you can name it as per your convenience. So let's say I name it as VCVR2 OCI 2702. Rate limit, let's say again I take 100 Mbps. Again, you have the option of PayG, which will show you the hourly billing. Let's say for demo purposes, I take it as 12 months, no upfront payment. You will get the price summary for 100 Mbps of bandwidth towards Oracle Cloud. Of course, these are the list prices. And you go ahead and click on next. Again, it will take you to the checkout page. Click on monthly. I'll provide the PO details later. Again, automatically, since I've placed it in Mumbai itself, it is choosing the billing profile automatically. And then I go ahead and place the order. Again, once the order is successfully placed, it will take you back to the services page under the virtual connection section. So as you can see, the link from your virtual router towards your Oracle cloud has also been created. This has changed to configured. The ping has gone to my AWS console. The moment that ping is accepted and the configuration is done from your end, the AWS cloud connectivity will also go live. And similarly for Oracle cloud as well, the virtual connection has been created. So this is how easily you can spin up connectivity, do a multi-cloud connectivity in a matter of minutes through our platform. If there are any questions, we'll be happy to take them in the chat box towards the end of the session. Thank you everyone for your attention and time. Over to you, Raghav.
Thank you, Yash, for this demo. And as we move ahead, uh, uh, and since we have learned around what AI workload and what we have created for to optimize the network, uh, and have seen that how multi-cloud connectivity can be easily created using Polarin as a platform. And now we are moving towards what we have towards the end for every customer or for every enterprise who intend to join or who intend to use Polarin. or try the Polarin platform. So we offer free POC for Polarin connectivity. And it's a free day 15-day free POC, no questions asked. And this definitely will ensure that how your network is performing. You can see and witness on your own that what we are saying, what we have shown is actually working for you or not. So definitely, we cover all the cloud regions, which is AWS, Azure, Google, and Oracle Cloud. You can connect your data centers as well there and then. And bandwidth, you can have the connectivity up to 10 Gbps during the free POC. And you can provision the port as 1G and 10G. So as you have seen in the demo platform, it took maximum 2 to 3 minutes to connect two cloud environments. And similarly, you can connect any network endpoint. So we are happy to cater your request and questions now, uh, and we'll be happy to take up if there are any request for the free POC as well, if you want to try our network services and platform. Yeah. Thank you, everyone.
Thank you, Mr. Raghav and Mr. Yash, for this insightful session. The perspective of transitioning architectures for AI first environments was extremely valuable for us as well. Moving on to questions, I'll take the first one from Mr. Dharma. Are there any guardrails available to customize the network monitoring?
So there are, so you can customize the thresholds and everything, and but it is very much at a basic level or the development level. Currently, we offer the alerts for the standard practices, but as we develop the monitoring platform, which I showed specifically for AI workload, we'll optimize it, and definitely we'll have the customizable guardrails that you can set for your alerting system, set for your monitoring, etc.
All right. Moving on to the next one by Mr. Roy. Can Vista on Polarin connect old network with new network?
No, so Vista works with the connectivity, works for the monitoring of the connectivity that you established via Polarin platform, which is running on Lightstorm's network. So any network or any connectivity that you establish between clouds, between data centers, Vista monitors that connectivity, and you can enjoy that monitoring on a single dashboard whenever you provision a network.
All right. We hope that answered your question. Moving on to a question by Mr. Nishant. He wishes to understand if Lightstorm works on existing MPLS providers or new fiber channel providers because I'm sorry, and he strongly hopes this is a service that Lightstorm provides.
No, so since I've mentioned that Lightstorm runs its own fiber cable across the country, across the globe now, we run our own DWDM enabled fiber, which is at the best stage for the cloud and AI workloads. So that is our own fiber running across. And so if you want to connect your network workloads in cloud data center, your on-prem setup, or in any of your enterprise setup, you can use Lightstorm connectivity, but doesn't work with the existing fiber network. Of course, many of the enterprise use us as primary or secondary provider to have the redundancy in place. So let's say if any bank might use Tata as well, might use Airtel as well, and might use Lightstorm as well to have a service provider level redundancy. So they use all three fibers in place. But yeah, our solution doesn't work on any other MPLS network. Polarin works on the Lightstorm's network in place.
All right. And then I'll take the last one from Mr. Puneet in the interest of time. In training versus inference light, latency was shown important under inference, which I think is more important in training for GPU to GPU models as
Yeah.
compared to the inference one.
Yeah. So, of course, when we talk about inference and training, the priorities are very much clear, right? Latency matters more for inference because inference is real time, right? And it is user facing, while training is batch and throughput driven. But when we talk about training, it runs over hours, over days, because you're constantly training your GPUs, moving large amount of data, moving petabytes of scale of data, and it needs to be transferred between GPUs, can be within the same data center also. right? But when we talk about the latency or the inference use case, it's more like a real time or instant response time that matters for the user. So that when any user is talking to a chatbot, talking to, let's say, fraud detection mechanism, some recommendation engine. So every microsecond or every millisecond result matters a lot. So that's where latency play a crucial role than training of the data. For training, the path between the GPUs, which is the connectivity, the throughput, the deterministic bandwidth, matters a lot than the latency. I I hope I was able to answer that.
Raghav, very quickly, we have three more questions. Would you like to answer them right now or later?
Yeah, I can take that up.
Okay, so we have a question from Mr. Nishant again. If Lightstorm works on SDWN.
So that is similar to MPLS. So yeah, as I've mentioned, Lightstorm works on its own fiber that we are running across country, and if you provision any connectivity via Lightstorm Fabric, you can provision it via Polarin platform. It's a single stop solution for you, and can monitor the entire network connectivity on a single platform.
All
But
right. And the next one is from Mr. Narendra Sharma, who wishes to understand how much latency is accepted in the AI workspace.
So that varies from specifically number of GPUs, how are they located, how critical is your workload. But usually, as a thumb rule, it is recommended to have less than 0.5 millisecond, which is approximately 500 microsecond. So anything less than 0.5 millisecond should work.
Okay, all right. Now the final one for today is by Mr. Dipanshu Gupta. He wishes to understand if AI native networks promise optimal GPU utilization and can they provide a provable upper bound on GPU ideal time in distributed clusters despite unpredictable latency and data gravity, or are we ultimately dependent on probabilistic scheduling?
So when we talk about the AI native network, we need to understand that it's a completely SLA driven, latency sensitive, and a private backbone connectivity running through fibers. It does not involve internet in between. Hence, the I would say the schedule, the latency is very much deterministic and predictable, and it is completely SLA driven. But when we are connecting via internet, the latency is very fluctuating, the jitter is pretty high, and your GPU idle time is very high, which costs you a lot. So ensure that you connect on a private backbone, which is having a deterministic bandwidth, and hence your latency is taken care of, and it's SLA backed.
All right. With that, we've come to the end of the Q&A round. And before we go on to the winners piece, we have a very small poll for you. So, for the audience today, Bhavna, can you please bring the poll up? Can we get some responses, please, from the attendees? We're going to keep this poll on for the next 30 more seconds. All right. With that, we come to the end of the polling round. Now let's move on to the winners, the most exciting part of this segment. Firstly, the winner of the best question award is Mr. Nishan Bansal. Bhavna, over to you for the spin the wheel segment.
Yes. So here we go.
Oh, congratulations, Mr. Sunil. Are you here with us right now?
Okay, we'll go the second time. So here we go.
Mr. Umesh.
And we'll go the third time and the final time. Yeah.
Mr. Sridhar, do we have you with us? It looks like we don't have any winners for the spin the wheel. Uh, as we conclude today's session, on cloud native to AI native rethinking network architecture, we would like to give a heartfelt thank you to Mr. Raghav as well as Mr. Yash for joining in, and our super enthusiastic audience who stayed tuned with us throughout this session. This is Nishtha Gupta signing off the day until we meet the next time. Have a wonderful evening ahead.